Swayam Prabha. Digital India. Educated India.
Hello dear friends, welcome to this fourth lecture of Module 8 on rock load and support system. In previous lectures, we have elaborated about empirical and semi-empirical approaches for estimation of rock load or ground pressure. Now in this lecture, we will learn about structural defect approach and rock support interaction. In this lecture, we are going to elaborate about structural defect approach and rock interaction approach. Regarding this, we are going to cover about introduction, structural defect approach, and then rock support interaction approach. Friends, as you know, the structural defect approach, as the name indicates, this approach involves the determination of potentially unstable block of layers of rocks in relation to the spatial orientation of joints and opening geometry. The total potential volume of rock strata prone to fail into excavated opening depending on the number of joint sets and the tensile strength of rocks as well as shear strength of joints. The thinly layered rocks may not be able to resist the tensile stresses. Therefore, it is important to make the tensile stresses close to or below to the strength of rocks. The tensile stresses developed along an opening is due to gravitational forces. In construction of rock engineering structure or engineering geological structure in layered rock mass, the layered may be also subjected to loading conditions such as encountered in cantilever beam in structural engineering requires special attention to counter the effective stresses. Friends, this approach is also close to the block theory, and this block theory developed by Verike in 1964 and John 1970 and Lunde in 1970. Later on, this concept was advanced or advocated by the Goodman and Sai in 1985. What is structural defect approach? When we are going to take this type of strata having some discontinuity or belonging to different geoground condition or geoground, then according to this concept, there is a formation of geometrical blocks of rocks. Therefore, it is geometrically determines potentially unstable block that can exist in geological strata intersected by variously oriented joints. Therefore, it is also called as geometrical approach in association with structural defect approach. Principally, the structural defect approach is due to presence of joints or discontinuity. As per this concept, the block of various sizes may be the potential source of rock load and hazards in an excavated opening or foundation, causing failure of opening as well as slides nearby foundation or displacement of foundation. This concept may also apply to highly porous weathered and fissure rock strata and some type of soils also. You can see, according to this, along this discontinuity there is formation of this type of block in 3D, and which is prone to slide or prone to failure. When we are going to create this type of opening, the concept presents dimension of the potentially unstable block or layer of rock in relation to the spatial orientation of joints and opening of geometry. If this is the joint set J1 and this is the joint set J2, due to intersection of this joint J1 and J2 along with surface of opening, there is a formation of blocks. The failure of an excavated or excavation of opening initiate at the boundary of the movement of a rock block along this joint, and this block is going to move towards the downward and fall in excavated opening due to low shear strength of this boundary, or these boundaries are unable to resist the shear stresses developed due to excavation of this opening. This loss of first block, when this first block is going to move down, then the spaces available for the second block, third block, fourth block, so these blocks started covering this space and move toward the downwards, and leading to this process is going to lead about the degradation, possibly leading to massive failure or ultimately collapse of created opening. Here some limitation about assumption of the rock blocks. The rock blocks form due to intersection of joints and surface of opening. This block should be rigid in nature. A block subjected to deformation or loosening, then such type of block is not under consideration for this purpose. Next thing, this concept is not valid in case of toppling failure. As far as this concept is elaborated, then you can see this J1 joint, J2 joint responsible for formation of this type of blocks after intersection each other and make meeting with at the shoulders of opening and responsible for creation of this type of block. This block under influence of gravity try to move downwards. Due to this, the other blocks which are associated with this block, block number 2, block number 3, block number 4, started supplementing this gap formed by this block. So the load coming on the support system is simply the weight of block. For calculation related to block for unit thickness, we can elaborate in this way. W is equal to, that is the weight of the block is equal to unit weight of rock material multiplied by this expansion L divided by 2 into L minus tan alpha 1 into tan alpha 2 divided by tan alpha 1 plus tan alpha 2 minus R0 plus 2 theta R by L minus cos theta. This relationship is suitable for determination of weight of block, where this L is the width of opening, this gamma is unit weight of rock, R0 is the radius of arch, and theta is the angle of arching, and alpha 1 and alpha 2 are the inclinations of the set in plane of cross section. So in this way we are going to determine rock load or ground pressure coming on supports. If the slide is located on the walls of this opening, then there is a development of these forces, normal and this tangential. In this case, the weight of this block is less than or lower than the weight of block formed in case of roof zone. The weight of the sliding prone block, the rock load is found to be less than that in case of the roof due to shear resistance of the set on which sliding is possible. As per limiting equilibrium state of blocks in the side walls, we can able to calculate the force F dash, summation of all F dash is W sin alpha 1 minus PS minus S is equal to 0, where this PS is this force and S is this force. This is the N force, N component, where and summation of F double dash is equal to W cos alpha 1 minus normal stress is equal to 0, where this S and N gives the direction parallel and normal to the sliding plane. Further, here we can elaborate the summation of F and NS stand for total normal and shear forces, as this diagram is going to show. Here normal and shear forces, S for shear and for normal. Assuming a frictional resistance on plane alpha, the limiting state is S by N is equal to tan phi 1, and the required resistance from the support member can be established P as a support pressure, and beared by the support member is a W sin alpha 1 minus phi 1 divided by cos phi 1, where W is the weight of sliding body or block, alpha 1 and alpha 2 are the inclinations of sets on which sliding is to occur, and phi 1 is a friction angle of. In this way, we have discussed about the structural defect approach or block theory, because here deformation commenced in form of movement of block under influence of gravity, and the movement of block is going to show the space or create the empty space for movement of the other block. In this way, the whole rock mass is going to show some deformation, and finally the created opening got cleared. Next approach is a rock support interaction approach. It is based on concept related to back analysis, where we are going to analyze first about the condition of support system subjected to rock load. After analysis of the condition and feature preserved in support system, we are going to predict about the magnitude of rock load R. This concept was first suggested by Fenner in 1938 and later on advanced by the Rebsbeek in 1964 to 1965 and implemented in this concept for the tunneling in Alps in 1969 in metro tunnel developed in Frankfurt. This approach later on became the backbone of modern tunneling method, popularly known as New Austrian tunneling method, proposed by Reykjavik in 1964 in association with the work of Picher in 1964. This approach was widely utilized throughout the world except England and France, where they have named this approach as characteristic curve method and convergence method for the same concept based on the rock support system. In this case, if a circular underground opening is situated in hydrostatic state of stress and the behavior of rock strata is to be elastic or brittle plastic. In addition, the gravitational force is come into existence following the plastification of rock. The conditions necessary for plastification is the first roof of the opening. The normalized internal pressure can be shown to be by using Mohr-Coulomb's criteria. Classical Mohr-Coulomb's criteria, tau is equal to C plus sigma and tan phi, where tau is representing shear strength or shear stress, C is representing cohesion, sigma n is a normal stress, and phi is angle of internal. Rock support interaction approach, as per concept, the Fs is a ratio of the pressure on the support system with respect to the stress condition, that is summation of FTGP plus FGR. This FTGP and FGR, these two are the support reaction curve and ground reaction curve. This FTGT can be determined by this relationship 1 by Q plus 1 into 2 minus sigma C by sigma 0 into A by Rp into Q star minus 1, where as FGR can be calculated as 1 minus A by Rp into Q minus 2 multiplied by unit weight of the rock into A by the initial stress and then multiplied by 1 by Q minus, where PS is internal pressure provided by the support member, sigma 0 is in situ stress or initial stress or virgin stress, and Q is the relationship as 1 minus sin phi divided by 1 plus sin phi, where the sigma C is uniaxial compressive strength of rocks and A is the radius of opening, where Rp is the radius of elastic plastic boundary and Q star is representing 1 minus sin phi star divided by 1 plus sin phi star, where this gamma is representing the unit. Phi is a friction angle of intact rock and phi dash is a friction angle of the plastified rock. The above equation consists of two parts. First one resulting from the true ground pressure and the second one from the weight of rock in the plasticide zone. Therefore, the function FTGP is a monotonically decreasing function, while expression FGR is a monotonically increasing functions. We can see here the FTGR is a representing monotonically decreasing function, where the FGR is a increasing function. As per Reykjavik in 1964 in North Philosophy of Tunneling, according to him, the support should be installed before the minimum of the function Fs is. The load to be carried out by the support member is to be the one at which the ground response curve intersect the support reaction. This ground response curve intersect the support reaction curve, and this pressure we are going to utilize for the installing support system. The load on the support result from the restriction of the inward movement of the surrounding rocks coming on the support system, and there is an optimum support load to be encountered by the support system, which correspond to intersection point of the reaction curve as number 2 in this. Friends, this concept we have developed based on material available in Tunneling in Weak Rock, published in Elsevier Geoengineering book series edited by Professor John A. Hudson, Imperial College London, pp 1 to 480. Then this block theory concept was advocated by the Goodman and Sai in 1985, and this book, Tunneling and Weak Rocks, written by Bhavani Singh and the R.K. Goyal in 2006. It's a very nice book. And the paper written by Goodman, Ari and Shiji in 1985 about the block theory and its application to the rock engineering in developed Cliff, New Jersey. Prince Hall is a good book for different rock mechanics related problems as well as development of this concept available in this book written by Goodman, and this paper is fully devoted. Initially, the block theory was proposed by John Cavey in 1970 in his paper Engineering Analysis of Three-Dimensional Stability Problem utilizing the reference hemisphere, presented in Second Congress International Society of Rock Mechanics in Belgrade, that is available in volume 2 and ranging in page 3142. Then material for this lecture I have collected from book written by Bhutkuri V.S. and Katsuyama in 1994, Introduction to Rock Mechanics, published by Industrial Publication and Consult in Tokyo, Japan, and this book having pages from 1 to 272. Then paper related to block theory written by Lunde et al. In 1970, Lunde P., Weger G., and the Bormelinger R. about the stability of slope by graphical method, published in Journal of Soil Mechanics, Foundation Division, ASCE, volume 95 and pages 1411 to 1434. Then the Wittke W. partial support from this paper 64, a numerical method of calculating the stability of slope in rock with the system of plane slope, actually written in German and then translated in English. Felschnick and Engineer Geology Supply 1, page 103 to 1. We have discussed about the structural defect approach. The structural defect approach is similar to the block theory, and as per concept proposed by Goodman and Sai in 1985, the blocks of rock that should be rigid in nature form due to intersection of joint where the joint should be more than one. The intersection of joints along the surface of opening going to create block rigid in nature where the boundary of the block along the joint showing minimum shear strength, although created opening experience tensile stresses, induced tensile stresses along this opening. Therefore, this type of boundary is unable to sustain with induced stresses and starts moving towards the downside in opening under the influence. When one block is going to move down, then another block is going to take the place of previous one, and then next is going to cover the second block space. In this way, the whole strata is going to show the failure or leading to failure. In this way, the deformation of rock strata is taking place due to movement of individual rigid block. This concept of block theory was later on utilized for development of numerical method and number of software for solving complicated problems related to engineering geology regarding stability of underground excavated opening or underground spaces and stability of dam foundation or stability of natural slope, rock cut slope and others. As far as the structural defect approach is concerned, it is based on concept of joints and intersection of joints along with joint opening surface responsible for formation of blocks of rock, where these blocks should be rigid in nature and the joint set should be more than. The opening surface and interaction of joints are responsible for formation of rock blocks, and the movement or deformation and deterioration takes place due to movement of rock. The deformation occurs due to displacement of the rock blocks. When one rock block is going to move toward the downside, then the another block is going to take the place of previous empty space. In this way, one by one, the strata consisting of various rock blocks, which was also indicated by this relationship RQD by Jn, representing the block size by Barton et al. In 1974, justified by this concept. The ground is made up of different rocks, and the movement of blocks is going to deteriorate the strength of ground and resulting in failure of ground. If such type of situations occur in underground opening, then there is a failure of roof. The weight or the rock load caused due to failure of roof block is more in comparison to the blocks formed at the wall side due to differences in shear resistance working in case of roof and in case of sidewall. The displacement of the rock block responsible for formation of damage zone or deformed zone around an opening and resulting completely failure of opening. The rock support interaction approach is basically based on back analysis and following the Mohr-Coulomb's criteria. The Mohr-Coulomb's criteria deals with the shear strength of the rock or the shear failure under confinement. The shear failure, we are recognizing tau is equal to C plus sigma and tan phi, where the C is a cohesion and cohesion is nothing. Cohesion is due to arrangement of constituents in particular material belonging to rock strata, rock mass or soil. The forces acting between these grains of rock is finally resulting the cohesion of the rock. If the forces or stress acting between these two grains of the rock is less, like in case of sand, where the grains are almost detached from each other or simply in contact, showing very less or close to zero stress condition or binding condition. Therefore, in case of sand, this C should be close to zero. In case of soil, we are having some adhesive forces acting between these two grains or grains of soils. Therefore, the soil having some C value, cohesion value. However, in case of rocks, as the grains are intactly attached with each other, therefore, in case of rocks, we are having more cohesive. This cohesive stress and the addition of the normal stress coming due to overlying rock strata and the angle of internal friction, if we are going to see, we can see, if we are going to plot here sigma normal and here shear stress, then this type of envelope we are going to get after plotting this Mohr-Coulomb, where this angle is representing phi. This angle is actually representing angle of internal and C is a cohesion. In this way we are going to determine shear strength of rock. Elaborating this, we are going to see about the variation of the ground reaction curve and variation of the support reaction curve in our specific manner. Dear friends, in this class we have elaborated about the concept of structural defect approach. In structural defect approach, we have elaborated about the formation of rock blocks due to intersection of joint more than one along with surface of created opening. This block we are going to assume rigid in nature and bounded by boundaries condition formed by intersection of joint and surface of opening. This boundary of the block, that is bounded by joints and surface of opening, where these joint interfaces are weak in case of tensile stress condition, and started moving toward the downwards. Later on, the space available by the movement of this initial block exposed in roof of opening, supplemented by another block, and the space created by this movement of another block completely occupied by next another block. This process is continuing, reintegrating about the strength of ground and commencing about the failure of opening. And the rock support interaction approach basically based on the back analysis, where we are going to analyze about the response of support system for prediction of rock load or ground pressure with help of two plots related to support reaction curve and ground reaction curve. As per Reykjavik 1964, the installation of support system should be at the point of intersection of the support reaction curve and ground. Next aspects we will discuss in our next class. Thank you very much.